Today we're going to go over the answers to the electrochemical problems that I gave you this week. The first part of these is understanding oxidation and reduction. This should be somewhat of a review because we discussed this in basic science, and so it should be hopefully a review for you. The first problem it says is problem number 2, which says identify each half reaction below as either oxidation or reduction. So before we do that, let's remember that Leo and Gur, if you lose electrons, you're oxidized. Lose electrons is oxidation, and Gur is gain electrons is reduction, or is being reduced. And just to recall, if something is being oxidized, it is a reducing agent, and if something is being reduced, it's an oxidizing agent. Okay, with that introduction, let's take a look at this first one. It says Cl minus, it should be 2Cl minus, goes to form Cl2. Now, in order for that to happen, each of these has 8 electrons. And in order for this to occur, it has 7 electrons each. So this has to lose, or on this side you write it as a gain. So this loses 2 electrons in order to have a 0 oxidation number. And since it loses 2 electrons, this will be oxidation. The second one is Mn2+ goes to MnO2. Now, in order to do this, you have to figure out what the oxidation number for Mn is. The most common oxidation number for oxygen is -2, so we'll use that as the oxidation number for oxygen. So, and the total here, because this has no charge, has to equal 0. So 2 times a -2 plus whatever Mn is has to equal 0. And so for that to work out, Mn has to be +4. So to go from +2 to +4, you have to lose 2 electrons. So again, we're losing 2 electrons, or on this side you'd write +2e, like that. And therefore this is also oxidation. So that's B. C is H2 goes to form, and I always put in to balance it 2H+. Now we're going from 0 to plus. In order to go to 0 to plus, again, we have to lose 2 electrons from this to get this. So this is also oxidation. And then the last one, NO3 minus, O3 minus goes to NO. Now the oxidation number here is +2. This one, because it has a -1 charge, the sum of the oxidation numbers has to equal -1. So if we assume this is -2, 3 times -2 is -6, and then whatever n is. So n -6 is equal to -1, so this has to be +5. So this goes from +5 to +2. In order to do that, you have to add or gain 3 electrons. And in order to do this, you have to gain 3 electrons. Since you're gaining 3 electrons, then this is a reduction. Okay, so that's important for our next step, which is problem number 4. Problem number 4 says to balance the equations below, assuming they're in an acidic solution. To balance these, you have to use half reactions. These are oxidation reduction reactions, and they are more difficult to balance, particularly by inspection. And so using the oxidation reduction technique is the best way to do that. So here's the first equation, put A. So we have peroxide goes to water, and plus 10 ion goes, and 10 2 plus ion goes to 10 4 plus ion plus water. So the first half reaction is SN 2 plus goes to SN 4 plus 2 electrons. The second thing that happens here is you have H2O2 goes to H2O, and you have to balance and in order to do that, you really have to start out with 2 of these to balance the oxygens and to get the hydrogen for that. And that's why it says that this is happening in an acid solution. So the thing that's being changed here is the oxygen. Oxygen here has to be a -1 for this to be +1. And oxygen here is -2. And so since you have 2 of these, you have to add, and it goes from -1 to -2. To go from -1 to -2, it has to gain. And for each oxygen, it gains 1. So overall, it gains 2 electrons. And so to balance these electron changes, you multiply both of these by 1. You don't have to do anything else. So if you sum all this, you get 2 hydrogen ions plus H2O2 plus SN2 plus goes to form 2H2O plus SN4 plus. And that's the right answer. And the fact that it is in an acid environment is where these hydrogens are coming from. So let's take a look at the next one. I'll leave that on the screen so you can see it. If we look at the next one, which is B, B is PbO2 plus Hg goes to form Hg2 plus 2 plus Pb2 plus. Okay, so how do we do this? Okay, so what we do first, we can start with either the Hg or the Pb, whichever one you want to start with. If we start with PbO2, we have this is -2 times 2 is -4, so this has to be +4. This goes to form Pb2 plus. Now we have to balance the oxygens here, so we have to add 2 waters here to balance that. And that means that we have to add 4 hydrogens on this side. Remember, it's in an acid solution, and that's why they told you that. So that's the one thing. And to go from 4 plus to 2 plus, you have to gain 2 electrons. The other half of this is Hg, and we're going to say 2 of these because we have 2 on this side, goes to form Hg2 2 plus. Now in order to do that, we're going from 0. Now each of these is 1 plus, so 2 of these, we're going to add 2 electrons to this side. So again, because you have 2 electrons here and 2 electrons here, that balances, so you don't have to multiply it by anything. So the overall reaction is 4 hydrogen ions plus PbO2 plus 2 Hg goes to form Hg2 2 plus Pb2 plus 2 H2O. And that's the answer. C, Al plus dichromate ion goes to form Al3 plus chromate, or chromium 3 plus. So let's just start with the chromium one first. We have C2O7 2 minus. It's going to go to 2 Cr2 3 plus. We have 2 here, so we have to have 2 here. Okay. In this situation, this is a minus 2 times 7 is minus 14, but the overall is minus 2, so minus 12 has to be balanced by chromium. So this has to be plus 6. So this goes from plus 6 to plus 3 by the addition of 3 electrons. Now balancing the oxygens out, we have to get 7 H2O on one side and 14 hydrogen ions on the other side. Now the other part of this is Al goes to form Al3 plus 3 electrons. And again, the electrons balance out, so what you're left with is 14 H plus Cr2O7 2 minus plus Al goes to form 2 Cr3 plus Al3 plus 7 H2O. And so that's the balancing of all 3 of these. Let's move on one more before we change videos, and we're going to do number 12. And number 12 states that assuming the schematics below for galvanic cells as written, identify the half reactions that are occurring in each. Okay, this looks at how these galvanic cells are written, and what we have here is Mg solid with one line, then Mg, probably 2 plus, which is the most common, 2 plus. So that's one part of the galvanic cell. And then they'd use a double line to show the other half, which is Cu 2 plus, and then Cu. And that's the end of it. And so actually, we don't need this line right here. And this is this. So the first half reaction is going to be Mg goes to Mg 2 plus. In order to do that, Mg has to lose 2 electrons. On the other side, you have Cu 2 plus that has to gain 2 electrons to form Cu. So this top reaction, the losing of 2 electrons is the oxidation side, and the gaining of 2 electrons is the reduction side. And by convention, the reduction side is usually on this side, and the oxidation side is usually on this side. B. We have nickel solid going to nickel plus 2 aqueous, and that's one side of the equation, or the cell. And then the other side is silver aqueous going to silver solid. And this is the same as the last one. We have nickel going to nickel 2 plus 2E. And for every one of those, you're going to have 2 of the other ones. You're going to have 2 silvers. This whole thing is going to be multiplied by 2. 2 silvers plus 2E goes to form, or plus E, the 2's on the outside, goes to form silver solid. And again, this is the oxidation side, this is the reduction side. And the anode is where oxidation occurred, and the cathode is where the reduction occurs. So the anode of any battery, anode, and cathode.